Now, for the continuation of our class, now we are going to discuss the inverse hyperbolic functions of Z. Now, to start this topic, we are going to solve now what is the arc sine hyperbolic of Z. So you can read that as the arc hyperbolic sine of Z. Now, our solution will start by letting the variable A equals to the arc sine hyperbolic of Z. So what are you going to do? You are going to transpose arc sine, hyperbolic sine, to the other side of the equation to become sine hyperbolic A. So this is equal to, take note, now we have done that before, that is e raised to A minus e raised to minus A all over 2, that is equal to Z. Now if we are going to cross multiply, this will become e raised to A minus e raised to minus A equal to 2 times Z. Multiplying that by e raised to A to make the equation quadratic, this will become 1. This will become 2Z multiplied by e raised to A. Now rearranging that equation to become a standard quadratic equation, or we can equate this to 0. Now this will now be our quadratic equation of e raised to A. Then to solve for e raised to A, that is just the negative B. In that case, that will become positive 2Z plus or minus B squared. In that case, that will become 4Z squared minus 4AZ, AC, A is 1, C is also, C is negative 1, all over 2 times A. Now, if you are going to simplify the terms under the root sign, take note, that will become 4Z squared plus 4. Now you have a common term that can be factored out later on. Now if we are going to factor out 4, since 4 is a perfect square, we can make it 2 outside the square root sign. So leaving you Z squared plus 1. Now, if we will divide the numerator by 2, the result will be Z plus or minus square root of Z squared plus 1. That's the value of e raised to A. Now, if we are going to take the logarithm of the whole equation, that will become A multiply A, that is equal to the logarithm of Z plus or minus square root of Z squared plus 1. Therefore, your arc hyperbolic or your arc sine hyperbolic of Z is ln Z plus or minus square root of Z squared plus 1. That will be your answer. Take note of the formula because you will be needing that later on. For our next example, we are going to solve the arc hyperbolic cosine of Z. Now, start your solution by letting A equals to arc hyperbolic cosine of Z, and then transposing hyperbolic cosine to the other side of the equation, that becomes cosine hyperbolic of A, leaving you Z on the other side of the equation. So cosine hyperbolic of A is equal to e raised to A plus e raised to minus A all over 2. Now, if 2 is multiplied to Z, this will become your equation. Now, multiplying this equation to e raised to A, this will be e raised to A quantity squared. This will become 1. This will become 2Z e raised to A. Now you have a quadratic equation. Now, if we will rearrange the quadratic equation and equate that to 0, we can have our quadratic, a standard quadratic equation of e raised to A. Now, to solve for e raised to A, that is just the negative B, which is 2Z, plus or minus square root of B squared, that is 4Z squared, minus 4 times A times C, all over 2 times A. Now, if we are going to simplify it further, we are going to factor out 4 and put that outside the square root sign. Since that is a perfect square, that becomes 2, and the remaining terms inside the square root sign is z squared minus 1 all over the denominator 2. Now, if you divide the whole numerator by 2, the result will be z plus or minus square root of z squared minus 1. That is your e raised to a. Now, taking the logarithm of both sides, that becomes a. The other side becomes ln plus or minus square root of z squared minus 1. Therefore, your arc hyperbolic cosine of z is ln z plus or minus square root of z squared minus 1. All right. Now we go to the third example. For our third example, we have number 3. We have sine, we have cosine. Oh, this time we will solve, or we will evaluate the arc hyperbolic tangent of z. So number 3, what is the value of arc hyperbolic tangent of z? What's the value of that? Okay, now let a be equal to arc tangent hyperbolic of z. Now, if we are going to transpose that to the other side, it will become tangent hyperbolic. So tangent hyperbolic of a is equal to z. Now we know the hyperbolic tangent of a, that is e raised to a minus e raised to minus a all over e raised to a plus e raised to minus a, which is equal to z. Now, if we are going to cross multiply that, we have e raised to a minus e raised to minus a, which is equal to z times e raised to a plus z times e raised to minus a. Then, if we multiply the whole equation by e raised to a, it becomes a quadratic equation of e raised to a quantity squared minus 1 equals to e raised to z times e raised to a quantity squared plus, take note, e raised to a minus times e raised to minus a equals 1, so the remaining there will become z. Now, if we are going to combine like terms, this will become e raised to a quantity squared minus z times e raised to a. Take note that is quantity squared equals to 1 plus z. So if we are going to factor out e raised to a quantity squared, we have 1 minus z. On the right side, we have 1 plus z. Now solving for e raised to a quantity squared, we have 1 plus z all over 1 minus z. Now if you are going to take the root or the square root of both sides of the equation, this will leave you the square root of 1 plus z all over 1 minus z. Or you can transform that to exponent form, that is raised to 1/2. Next, we will take the logarithm of both sides of the equation. So this will now become a, which is equals to, take note of the logarithm of the power. So the power will become the multiplier of the logarithm of 1 plus z all over 1 minus z. Therefore, the arc tangent hyperbolic of z is simply equal to the logarithm of 1 plus z all over 1 minus z. Now, let's solve one problem here. I want you to take out your calculator and a piece of paper. Now we are going to solve this problem. So this will be our example number 1. So for this example, we are going to evaluate the arc. We are going to evaluate, not 6 minus j. We will erase this one. Okay, erase, erase. Okay, we are going to solve for the arc hyperbolic cosine of 6 minus j. But this time we are going to use long method. So to solve this, we are going to start our solution by letting a equals to arc hyperbolic cosine 6 minus j. Note, we are going to use long method. Now, in your assignment, now try to solve all the problems using long method. In that case, in that way, you will never forget how to solve the problem. If you will just use the formula, no, there is a big chance that you will forget that formula after your course. Okay, now this will become cosine of a hyperbolic equals to 6 minus j. Now, since if you are going to multiply 6 minus j by 2, that will become e raised to a plus e raised to minus a, which is equals to 12 minus j2. Then we will multiply the whole equation by e raised to a to make it a quadratic equation. Now, for this quadratic equation, now we will equate this to 0 to become a standard quadratic equation. Now, to solve for e raised to a, that is just the negative b. So take note, negative of negative 12 becomes positive 12 minus j2 plus or minus square root of. Now, if we are going to square b, take note, b 12 minus j2, now they have a common term, common value of 2. So that is 4 times 1 times 1, that's the value of AC, all over 2a. Now for the terms inside your square root sign, take note, 12 minus j2, they have a common factor of 2. So if you are going to take out 2, you are going to accompany the exponent. So that becomes 2 squared. Now 2 squared is a perfect square number. So we can take that out by taking the square root of that. So that is the square root of 2 squared is 2 multiplied by the square root of the remaining part of your quadratic equation. Now, if you are going to simplify it further, this will become, take note, this will become 1 since 4 was factored out a while ago. Now, if we are going to divide the numerator by 2, this will become 6 minus j, plus or minus, square root of. Okay, we will expand this binomial. So this will become 36 minus 12j, minus 1, minus 1. Okay. So this will be equal to 6 minus j. Now we will combine like terms. So that will become 34 minus j12. That is the value of e raised to a. Now, solving for a, you are going to take the logarithm of both sides of the equation. Plus or minus square root of 34 minus j12. So try to solve this problem using the short method and compare your answers with mine. Okay. Now, I will give you 30 minutes to solve the following problems. So take out I think take out your calculator and 2 pieces of paper to solve this problem. So for 30 minutes only, you are going to solve number 1. What is the value of cosecant 5 minus j7? Remember, cosecant is just the reciprocal of sine. And for number 2, the hyperbolic arctangent of 1 minus j2. So for this activity, you are going to use long method. And of course, check your answer using the short method. So pause this video, solve the problem. All right, now time is up. The correct answer for problem number 1 is negative 1.75 times 10 to the negative 3 plus j 5.17 times 10 to the negative 4. For problem number 2, that is equal to 1/2 times the natural logarithm of -1 minus j. Okay? So I hope your answer is the same with mine. So see you next meeting.